A centrifugal governor is a specific type of governor with a feedback system that controls the speed of an engine by regulating the amount of fuel admitted, so as to maintain a near-constant speed, irrespective of the load or fuel supply conditions. It uses the principle of proportional control. It was invented in 1788 by James Watt to control his steam engine, where it regulates the admission of steam into the cylinder. Its widest use was on steam engines during the steam age in the 19th century. It is also found on internal combustion engines and variously fueled turbines, and in some modern striking clocks. Operation. The device shown is from a steam engine. Power is supplied to the governor from the engine's output shaft by a belt or chain connected to the lower belt wheel. The governor is connected to a throttle valve that regulates the flow of working fluid supplying the prime mover. As the speed of the prime mover increases, the central spindle of the governor rotates at a faster rate and the kinetic energy of the balls increases. This allows the two masses on lever arms to move outwards and upwards against gravity. If the motion goes far enough, this motion causes the lever arms to pull down on a thrust bearing, which moves a beam linkage, which reduces the aperture of a throttle valve. The rate of working fluid entering the cylinder is thus reduced and the speed of the prime mover is controlled, preventing over-speeding. Mechanical stops may be used to limit the range of throttle motion, as seen near the masses in the image at right. Non-gravitational regulation. A limitation of the two-arm, two-ball governor is its reliance on gravity, and that the governor must stay upright relative to the surface of the Earth for gravity to retract the balls when the governor slows down. Governors can be built that do not use gravitational force, by using a single straight arm with weights on both ends, a center pivot attached to a spinning axle, and a spring that tries to force the weights towards the center of the spinning axle. The two weights on opposite ends of the pivot arm counterbalance any gravitational effects, but both weights use centripetal force to work against the spring and attempt to rotate the pivot arm towards a perpendicular axis relative to the spinning axle. Spring-retracted non-gravitational governors are commonly used in single-phase alternating current induction motors to turn off the starting field coil when the motor's rotational speed is high enough. They are also commonly used in snowmobile and all-terrain vehicle continuously variable transmissions, both to engage, disengage vehicle motion and to vary the transmission's pulley diameter ratio in relation to the engine revolutions per minute. History. James Watt designed his first governor in 1788 following a suggestion from his business partner Matthew Boulton. It was a conical pendulum governor and one of the final series of innovations Watt had employed for steam engines. James Watt never claimed the centrifugal governor to be an invention of his own. Centrifugal governors were used to regulate the distance and pressure between millstones in windmills since the 17th century. A giant statue of Watt's governor stands at Smethwick in the English West Midlands. It is known as the Flyball Governor. Another kind of centrifugal governor consists of a pair of masses on a spindle inside a cylinder, the masses or the cylinder being coated with pads, somewhat like a drum brake. This is used in a spring-loaded record player and a spring-loaded telephone dial to limit the speed. Dynamic systems. The centrifugal governor is often used in the cognitive sciences as an example of a dynamic system, in which the representation of information cannot be clearly separated from the operations being applied to the representation. And, because the governor is a servo mechanism, its analysis in a dynamic system is not trivial. In 1868, James Clerk Maxwell wrote a famous paper on governors that is widely considered a classic in feedback control theory. Maxwell distinguishes moderators and governors which control motive power input. He considers devices by James Watt, Professor James Thomson, Fleming Jenkin, William Thomson, Elie N. Foucault and Carl Wilhelm Siemens as an influence on cybernetics in a largely overlooked passage from his famous 1858 paper to the Linnean Society. Alfred Russel Wallace says of the evolutionary principle, "The action of this principle is exactly like that of the centrifugal governor of the steam engine, which checks and corrects any irregularities almost before they become evident, and in like manner no unbalanced efficiency in the animal kingdom can ever reach any conspicuous magnitude, because it would make itself felt at the very first step, by rendering existence difficult and extinction almost sure soon to follow." The cybernetician and anthropologist Gregory Bateson would observe in the 1970s that though seeing it only as an illustration, Wallace had probably said the most powerful thing that had been said in the 19th century. Bateson revisited the topic in his 1979 book Mind and Nature, A Necessary Unity, and other scholars have continued to explore the connection between natural selection and systems theory.